Prelim 2024 for Catholic High. This is for paper 1. Let's look at question 1. Which of the following is the same as 5080 cm? Okay, we have 4 options here. 5080 cm. Now, every 100 cm gives us 1 meter. So if you look at the hundreds, how many hundreds do we have? In the hundreds place is a 0, so that's 50. So it's definitely 50 meters. Your answer has to be 50 meters, not 5 meters. So the first 2 options are out. So 50 meters. Now you have you're left with 80 cm. So answer is 50 meters and 80 cm. Okay, which is option 4. Question 2, how many sevens are there in 2 and 4 sevens? Okay, what we need to do is you can change to improper fraction. Okay, so 2 times 7 is 14. 14 plus another 4 is 18. So how many sevens are there? That's 18. Okay, option 3. Question 3, what is the possible volume of hot water that fills a disposable cup completely? Okay, so a normal mineral water bottle, right, is about 500 ml. And ml is the same as cubic cm. So you should choose something that is close to that. Okay, definitely not meter cube, not cubic meters. That would be too much. And you're comparing with 32 and 320. 320 is slightly less than 500. It's closer to 500. So let's choose a 4. Okay, question 4. Figure below shows a cube. We are supposed to find the net of the cube. Okay, so we have 4 different options. Now what I'm going to do is I'm just going to choose one square to be the top, and then we check each of them. Okay, let's say I choose this. It doesn't have to be this one in particular, but let's just say I choose that. If this is the top, then try and figure out where are the sides. So this would be the side, this would be a side, this would be a side, this would be a side, and the last one will also be a side. Okay, so this will connect with this, and then it will wrap around it such that this one will be the connected to this side, but it already has one square connected to it. Okay, so you need to have a top, a bottom. You can't have 5 sides. So this one is out. Okay, next one, let's take maybe this one as the top. So if this is the top, then you have the sides, the sides would touch the top. Then the last one will not touch the top. Okay, so imagine this one wrap around this side, and this will go below, right underneath the top. Okay, so answer is option 2. Let's check for the other 2 in case there is to check if we made a mistake or anything. Okay, so let's say this is the top. Then those connected will be this. This is side, this is a side, this will also be a side, but this one over here will be the bottom, and this will also be the bottom. Okay, so you have 2 bottoms, which means that they would overlap, so 3 is out. Then lastly, you have this. Let's say we choose this to be the top. Then you have side, side, side. Now the other 2 will be the bottom. There's nothing connected to this side here. Okay, so this one is also out. So answer option 2. Okay, question 5. Which of which two lines are perpendicular to each other. Now, if you want to find perpendicular lines, right, just look at how the lines cut the grid. Okay, so look for where it starts cutting from one corner of the square to the next corner of the next square. Okay, example, or okay, we are looking for perpendicular. So let's just eliminate first. A, B, C, D, definitely not. They're opposite each other. C, D, and A, D. Okay, we'll check that. C, D, and A, B. C, D, and A, B. C, D, and A. Sorry. Wait. No. First one. Sorry, I see wrongly. So C, D, and A, B are not because they are opposite each other. Then C, D, and A, D. Okay, we have the other three options. Then one of them could possibly be perpendicular to each other. All right, now let's look at AB first. AB cuts across two squares. So the two squares I'm talking about is these two. Okay, it cuts nicely across two squares. Then if I look at AD, right, it starts here. It will not touch the corner of the square until it's over here. So that uh, this AD, right, actually only cuts from one corner of the square to the next across 12 squares. Okay, this is a 4 by 3 rectangle. So it will only cut from one corner to the next corner of the square, like basically cutting a rectangle into half, but it's cutting half of 12 squares. Okay, this first one, line AB is actually cutting half of two squares. Okay, then let's check BC. BC starts, let's say starting from B. It will only cut the corner of another square here. Okay, so I'm looking for the first corner that it cuts, which is this one. So if AB cuts across two squares, right, the perpendicular must also cut across two squares. And it has to be a rectangle that is perpendicular to the original one. Okay, so these two are parallel. So it will be AB and BC. Because BC is just an extension of this line here. Okay, so AB and BC, answer is 1. Now, if you look at CD, right, CD cuts across 3 squares. From one corner to the next corner is 3 squares. So it is not perpendicular to BC, nor is it perpendicular to AD. So to identify perpendicular squares, perpendicular lines, look for the number of squares that it cut. Okay, it has to be the same number. Question 6 was the mass of the packet of flour. Now you have the flour here. We have a 250 grams. Let's look at the breakdown by intervals. 1, 2, 3, 4, 5. 5 intervals from 0 to 250. So 250 divided by 5 is 50, which means that this is 50, this is 100, and so on. Okay, just check 100, 150, 200, 250. So yes, from 750, you jump twice. You jump by 50 grams twice. Okay, so 750 plus 50 plus 50, which is 850. So answer option 3. Question 7, which one is the smallest? Okay, if you want to compare, right, let's change all to the same number of decimals. So the first one is 0.110. Then the next one 0.200, 0.003, 0.040. The smallest ones means that they're if you start comparing from the tenth place, right? Smallest one will be zero. And compare the next place, 0.003 would be the smallest. Eight, line graph shows the amount of rainfall over 5 months. The amount of rainfall is not shown on the scale, so they're just giving you what it looks like, but not telling you exactly how much it is. So we're looking for the months, from which months to the next was the increase the greatest. So when we are talking about increase, right, it will have to go up. Okay, definitely have to go up. So March to April is out because that's going down. Now, if you go up, right, you want the greatest increase means it's the steepest, means it goes up by the greatest number of units. Now, if you just look at it, right, January to February, April to May will be one of the greatest. Okay, so we compare these two. Now, from January to February, it went up by how many units? So 1, 2, 3, 4, 5, 6, 7, 8. So 8 units, this direction. Then going up again from April to May, 1, 2, 3, 4, 5, 6, 7. So the greater increase will be from January to February. Number 9, Charles and Danny started running a marathon at 5:20 a.m. Charles was 20 minutes slower than Danny, who completed the marathon at 9:05 a.m. How long did Charles take to complete the marathon? Okay, so firstly, they started at 5:20 a.m. They ended, Danny completed at 9:05. So 5:20 a.m. to 9:05 a.m. Okay, 9:20 to 9:05. That's 3 hours to 9:20. 3 hours to 9:20. Sorry, 4 hours. Oh, sorry, 3 hours to 8:20. Okay, let's split this up. 3 hours to 8:20 a.m. Then how many minutes to 9:05 a.m.? It's less than an hour. So from 20 to 9 is 40, then you add 5 or 45 minutes. So 3 hour 45 minutes. But Charles was slower, so the time that he took was actually greater. So we add 20 minutes. 4 hour 5 minutes. Okay, so answer question 2. Question 10. In a school, the ratio of the number of boys to the number of girls is 1 to 2. Pie chart shows the different ways boys and girls go to school. Okay, so there's a group according to the boys as well as the girls. Um, the ratio of the number of boys to girls is 1 to 2. This means that the total of the girls has to be twice of the boys. Okay, so it's not like they're not equal. So what I'll do is I'll write down the ratio. Let's write down the ratio first. Okay, B to G, 1 to 2. what is the ratio of the number of boys who walk to school to the number of girls who walk to school? Out of the boys, right, we have 1/4 of them walking to school. So in ratio, boys that walk to school to the total of boys will be 1:4. Then the girls that walk to school to the total number of girls would be 20%, so 20 to 100, which is 1:5. Now you can't say that the ratio is 1:1 because we have to find out common base first. So example, if you have a 4 for the total number of boys here, we have to change this to a 4. Total number of boys has to be the same. Okay, the common base make the same. So this would be 8. Now the total number of girls we have here is 8, but here is 5. So we have to change both to 40, common multiple. So this would be 20. Okay, we have 40 here, so times 8. Okay, so now that the number of boys changed to 20, right? We have to change the other ratio, change it to 20 as well, so that they are the same. Now it times 5. Okay, then we get this. Now that the common base are all the same, we can say that the boys that walk to school will be 5 units, girls that walk to school will be 8 units, so 5 to 8. Option 4. Question 11. In this figure, we have a square A, B, C, and D. AD is equal to DF. So AD here, D to F here. Okay, then you have a 58 degrees, which is a ADF. So this is not equilateral. Find angle BEF. Okay, let's mark that out. This angle here. Okay, so firstly, okay, let me just mark out all the equal sides. Firstly, I have an isosceles triangle. Okay, isosceles triangle here. So, and we also have a square that is being cut to half. This ADB will be 45 degrees. Okay, so this ADB, this will be 45. Now, what I want to do is to find AED, this angle here, because this would be vertically opposite of what we want to find. Okay, so before we find AED, we will need DAF. So angle DAF will be 180 minus 58 and divide by 2 because you have isosceles triangle. Okay, let's write this down. Angle DAF will be 180 minus 58. Then we divide by 2. 180 minus 58 is 122. And when we divide by 2, this is 61 degrees. Okay, so this is 61 degrees. So now to find AED, we would take 180 minus 61 and minus 45. Okay, calculate that out. You should have 74 degrees. So this is 74, which means that our angle BEF is also 74 degrees. So option 2. Question 12, Ivan had 30 fewer sweets than Peggy at first. After he gave some of his sweets to Peggy, he was left with 28. Peggy had 3 times as many as Ivan in the end. How many did Ivan give to Peggy? Okay, let's start with model. Ivan had 30 fewer than Peggy. So Ivan, Peggy. So Peggy had 30 more. After he gave, as in Ivan gave some to Peggy, he was left with 28. So let's remove part of this. He's left with 28. Okay, so this is 28. And Peggy would be 3 times. So this is 3 units. And this would be 1 unit. So how many did Ivan give to Peggy? We're basically finding the shaded part. Now we can see that actually 1 unit is 28. So I'm actually interested in this part here, okay, which is 2 units. So if 1U equals to 28, that's 2 units because the total here is 3 units. Then you minus 1 unit. So the difference is 2 units. So to find 2 units, that's 28 times 2, 56. Now what is 56 made up of? It's made up of this box here, which is the same as this box here, and a 30. So I just need to minus a 30 and divide by 2. Okay, so 56 minus 30 is 26, and 26 divide by 2, 13. So answer option 1. Question 13. Figure 1 shows the rectangular paper is folded along the dotted line AB to form figure 2. So which of the following is or are true? Okay, so firstly, let's draw what the rectangle looks like before it's folded in figure 2. Okay, so it's something like that. Now, statement A, angle C and D equals to 90. C and D gives us 90. Is it true? Now, if C is the same as this whole thing here, then if you add D, it will be 90. Okay, how do we know if it's the same? I know that this is parallel to this. Okay, then we have parallel lines and a line cutting through. So angle C would be the same as this. Okay, you have your corresponding angle, the one that looks like F. So this here, same as that. So this is also C. So yes, it's true. C and D actually gives us 90. Okay, so true. So this one is out. This is out. So now we need to determine if C is true or not. Okay, from the looks of it, it seems like statement B is definitely false. But let's check anyway. The area of figure 1 is less than the area of figure 2. Uh, Figure 1 is actually bigger than figure 2. How do we see that? Okay, both has both has this part here, right? Okay, so both figure 1 and 2 has this. For figure 2, it's this one. Now the remaining parts, here, this one and this one, right? So this is definitely bigger than this one because it's the same as this, but there's an overlapping part. So this has to be smaller. Okay, so this one, figure 1 is bigger than figure 2, so this one's wrong. So figure 1 is not less. Area in figure 1 is not less. Okay, then how about statement C? both have at least a line of symmetry. Where's the line of symmetry? Now, figure 1, the line of symmetry is here. Okay, at least one. So there's another one which is like here. Okay, so A, yes, A has a line of symmetry. Now for figure 2, right, the line of symmetry is actually here. Okay, so it's true. This is true. So answer is option 3. Question 4, we're supposed to find the perimeter. In this figure, we have two identical quarter circles and a square. Length of a square is 7 cm. Now, perimeter of the figure. So I have a 7 here. And because this is also the radius of the quarter circle, so this must be 7. Okay. So here's 7 as well. So radius is 7 cm. Let's find the arcs, which will be this and this. Okay. Two quarter circle arcs. So to find the arcs of the quarter circle, you need to use the formula pi times diameter. So we need the diameter. 7 is the radius, so 7 times 2. Okay, 14 cm. So for the arcs of the two quadrants will be, because it's two arcs, right? Two arcs will give you one semicircle, so I use half. Half times pi times diameter. My pi is 22/7. Diameter is 14. Now without a calculator, can do this. So 2 and 22 can simplify. You get 11 here. 7 and 14 can also simplify. So this will be 2. So you end up with 2 times 11, which is 22. So 22 is the length of the arcs. Then add up all the sevens. So you have 4 times of 7, which is 28. So total perimeter is 28 plus 22. 50 cm. Answer option 2. Question 15. Mrs. Lim bought some pears and oranges and packed them into 2 bags. 3/4 of the fruits were in A and the rest in B. 4/9 of the fruits in A were pears. Half of the fruits bought were oranges. What fraction of the fruits in bag B were pears? Okay, I'm just going to write down all the ratios that I have. So firstly, 3/4 of the fruits were in A and the rest in B. So A to B first. A is 3/4, so B is 1/4. Then 4/9 of the bags of the fruits in bag A were pears. Okay, so pears that are in A to the total of A. 4/9 of it, so 4 to 9. Half of the fruits were oranges. So total pairs to oranges would be 1 to 1. Okay, equal number. So now let's find the common base. The number of fruits in A, here is 3, here's 9, so let's change it to 9. Then for this other ratio, it is the total of A and B that is the same as the total of pears and oranges. Okay, it's just a matter of how you're splitting them. Is it bags, A and B, or types of fruits? Okay, but the total number of fruits will have to be the same. So we find total. This would be a 12. This total here would be a 2, which means that I need to change to a 12. A multiplied by 6. So what fraction of the fruits in bag B were pears. Okay, out of all the pears, there's 6 units. Out of the 6 units, 4 units are in bag A. So the pears in bag B would be 6 units minus 4 units, which is 2 units, which means that the total, sorry, the pears is 2 units. What fraction of the fruits in bag B? So it's out of bag B. Bag B is 3. So I am looking at this 2 and then out of bag B. So bag B is 3 units. So answer 2/3. A, option 4. It is not 2/12 because they are asking for fruits out of fruits in bag B, not the total fruits. Okay, let's look at booklet B. Question 16. Round this number to the nearest hundreds. Okay, hundreds place is 9. Sorry, approximately. So approximation sign. Because it's a 7 behind, right? So you need to round it up. But because it's a 9, it will change the 12 to 13,000. So this is the nearest 100. Okay, so the 7 causes to go up, round up to the next 100. But after 9 it will change to a 3,000 instead. 17, find the value of 2.34 times 60. So without a calculator, this is how you do it. You can multiply by 6 first, then multiply by 10. So 2.34 times 6. In your answer, your decimal point has to be here. Okay, so 4 times 6, 24. Then 3 times 6, 18. Plus 2, so 20. 2 times 6, 12. Add 2 is 14. So 14.04 times 10, which is 140.4. Okay, 140.4. Okay, question 18. Find the value of 4 sevenths divided by 14. 4 sevenths divided by 14. Keep, change, flip. You want to keep the first fraction, change the sign to a times, and then flip the 14, which means that you get 1/14 instead. Okay, simplify first. 4 and 14 divide by 2, divide by 2. So 2 times 1 is 2. 7 times 7, 49. 2/49. Can't be simplified further. Question 19. Find the value of 10y/5 minus, 10w/5 minus w plus 1. And y is 4. So 10w means 10 times w, which is 10 times 4. So you just replace the w with 4. You should not have any more w's in your answer. Okay, if you find that you still have in your final answer, then something is wrong. Okay, so 10 times 4 first. So 40/5 minus 4 plus 1. We do the fraction first. 40/5 means 40 divided by 5, which is 8 minus 4 plus 1. Now, a common error is that students may take 4 plus 1 first, which you get 5, but actually that's wrong, because if you have a minus and a plus, you have to do from left to right. Okay, so 8 minus 4 first, which is 4. Then you add 1, which is 5. So answer 5. So if you had taken 4 plus 1 first, that's 5, right? You end up with 8 minus 5, which is 3. That's wrong. Do from left to right if you have both plus and minus. Question 20, write down all the common factors of 8 and 12. Okay, for 8, you have 1 times 8, 2 times 4, and that's all. For 12, 1 times 12, 2 times 6, 3 times 4. So common factors. You have 1, you have 2, and 4. 1, 2, 4. Question 21. Use all the digits to find, use all the digits 6, 5, 0, 8 to form, first one is greatest multiple of 5. Greatest multiple of 5 means that you either end with 5 or 0. But since you want the greatest number, right, you end off with the smallest one. Okay, we try to make the number as big as possible, so the last number will be a 0. Now just arrange them in descending order. So 8, 6, and then 5. 8, 6, 5, 0. Next one, the number closest to 6,000. Okay, so what are the, let's look at a number line. If this is a 6,000, then if this 5,000, this 7,000, let's find what's the closest number before and the number closest after to 6,000. Okay, so one has to be 5,000 something, since we have 5 as one of the digits. Then the other one will be 6,000 something. So we have 5 as big as possible. 5, 8, 6, 0. And after 6,000 will be 6 as small as possible. So 6, 0, 5, 8. Now on the number line, 5,800, probably somewhere here. 5860. Then 6058 is even nearer to 6,000. Okay, because you're comparing 58 versus 60. So the number that is closest will be 6058. Question 22, Jessie had a total of 30 20 cents and 10-cent coins. She exchanged all the 10-cent coins for 20-cent coins and had a total of 17 20-cent coins after the exchange. How many 10-cent coins did she have at first? Okay, so initially she had both types of coins. Then in the end, she only ended up with 20-cent coins. So in this exchange, there is a decrease in the number of coins. Let's find what's the decrease. Decrease in number of coins. From 30, it became 17. So it dropped by 13. Okay, let's take a look at one exchange. So every for every 2 10-cent coins, she get 1 20-cent coin. Okay, 2 10-cent coins, she'll get 1 20-cent coin. This is what's happening in every exchange. Okay, so whenever one exchange takes place, you are actually decreasing the number of coins by 1. So every exchange, it drops by 1 coin. So if it decreases by 13 coins, the number of exchanges would be 13 divided by 1. A total of 13 in the decrease, divide by every exchange, which is a decrease of 1. Okay, so there's basically 13 exchanges. 13 times when you exchange 2 10-cent coins for 1 20-cent coins. 1 20-cent coin. So if the question is asking how many 10-cent coins, right? 13 times of the exchanges involve how many 10-cent coins? So 13 times 2. Because every exchange you have 2 10-cent coins. So answer 26. Question 23, find the area of the shaded triangle. For this question, you just have to take half times base times height. But where's the base? The base is not 42, it's not 10, but 42 minus 10. okay, which is 32. So this part here, this is the base. Okay, so half times 32 times 15. Half of 32 will be 16. So when you do your working, you should be doing 16 times 15. Six times 1, 1. So 240, 240 square cm. Now the next one will be a little more challenging. A rhombus ABCD is on a square grid. Using the line RS, draw a square PQRS such that it has the same perimeter as A, B, C, and D. So basically the same perimeter as this rhombus here. Okay, so one side of the square will be the same as one side of the rhombus. So how do we know, or how do we check this? So when you want to compare the length of a line, right, you can look at this here. Okay, maybe a bit light. Sorry, let me try again. Look at the line AB. It is a line that cuts through 6 squares. Okay, like a 3 by 2 square. Sorry, 3 by 2 rectangle made out of 6 squares. So same for SR. Okay, can say like it cuts across 3 and then like down 2. Okay, across 3 and down 2. So okay, maybe we look at it. Across 3 and down 2. For this one is down 3 and across 2. So then since they cut across the same way, right? The length of SR and AB is the same. Okay, so the next thing to do is how do you draw a square using the same sides? And it has to be, for a square, right, it has to be perpendicular. So for SR to cut that way, you need to, in a way, like cut across the same manner. So for perpendicular line, instead of cutting across 3 to the left, right, we cut 2, and then we go up 3. Then that's your next point. We connect here. Here like that. Okay, then we do the same thing. Maybe from point, you can continue from this, either this point here or this point here. Let's continue from this point here. So I will cut across, it has to be the same parallel as SR, right? So I will cut 3 to the left, 2 down. So from here, 3 to the left, 2 down. Here. Here. 3 to the left, 2 down. So like that. Now you just need to connect this line here. Okay. Then because they say it's PQRS, PQRS, it has to go in order. PQR then S. If this is R, this is S, then this must be P, Q. So P, Q, R, and S. Okay, so to avoid confusion, let me erase all this first. Okay, All those markings you can do in pencil. So this is your answer for part A. Now for part B, what fraction of the area of rhombus ABCD is the area of the square PQRS? So firstly, I want to figure out, like, in that fraction, what should I be finding? First is the area of a rhombus. So what fraction of the area of the rhombus? So of the rhombus means that the rhombus below. And on top is the square. Okay, let's find the area. For the rhombus, right, it's made out of two triangles. The top triangle and bottom triangle have the same area. So the bottom triangle, rhombus, oops, ah, okay, for the rhombus is made out of two triangles. So we take 2 times, half times base times height. So half times the base is here, A to C. So that's four units, 4 squares. Then the height is here, 3 squares. So 2 triangles. Okay, that's why the 2 is there. 2 triangles. Okay, 2 times half is 1. 1 times 4 is 4. 4 times 3 is 12. So rhombus has an area of 12. Now for the square is a little harder to see. Usually for a square, you take like the side times the side, right? But it's impossible. It's not impossible, but over here, you are not able to find the length of this diagonal, this side, okay? Because it doesn't cut across the square along the sides. So we can't find this. But what you can do is to split the square into smaller triangles. Okay, let me show you how. So that it's easier to find the area of the triangles. So this is one triangle. Okay, and this is actually half of 6 squares. And you see it cuts. This is actually half of this rectangle, which is made out of 6 squares. Okay, so that one will be 3 squares, it's got 3 units. And another triangle here, 3 units. And then another triangle here, 3 units. And then another triangle here, 3 units. Then you have one in the middle, which is 1 unit. So for the square, it will be 3 times 4. Then you add the square in the middle. So that's 13. Okay, so square over rhombus. Square is 13 over 12, which will give us 1 and 1/12. Okay, it may not necessarily always be a smaller number on top, bigger number below. Okay, depends on what they're asking for. All right, that's for question 24. Let's look at question 25. Question 25. In 1 minute, machine A can pack 5 boxes of cookies, while B can pack 2 boxes of cookies. Both started packing at 12:50 a.m. At what time will both pack 175 boxes of cookies in total? Leave your answer in 24-hour clock. Okay, so let's write down in 1 minute first. A in 1 minute, 5 boxes. B in 1 minute, 2 boxes. Both machines started packing at 12:50 a.m. So you are supposed to combine them. So both A and B in 1 minute is 5 plus 2. 7 boxes will be packed in 1 minute. You have 175 boxes to pack. So the time taken would be 175 divided by 7 because 7 is every minute. And you get 25, so 25 minutes. So since they started at 12:50 a.m., let's do a timeline. 25 minutes later, it will be 1:15 a.m. Okay, 12 a.m. is midnight. So this is the midnight. And in 24-hour clock, 1 a.m. 12 a.m. is 0000. So 1 a.m. is 01. Sorry, that's a 1. Okay, 0115. Okay, so 0115. So you need to know your conversion. You may know how to do the steps, but at the end of it, if you can't do your 24-hour clock, then your answer would be wrong. Okay, let's look at the next one. Question 26. Annual rates to a country are shown in a table below. Quentin sent a letter that weighed 33 grams. He paid 56 cents. Okay, so how much did he pay for the first 20 grams of the letter, which is a question mark over here in the table. Okay, that's what we're trying to find. So he paid a total of 56 cents. Okay, and the 56 cents definitely included the 20 grams. So if it's 33 grams, what is the extra above 20 grams? What's the additional? So 33 minus 20, you get 13. 13 grams. But for 13 grams, how much would he have to pay for the additional part? The additional 10 grams, you have to pay 12 cents. So since this is more than 10, right, he has to pay 2 times of that. The excess 3 grams will be counted as another 12 cents. So 2 times 12 cents for this part here, okay? So 2 times 12 cents, which is 24 cents. Since he paid a total of 56, the rest of it must be for the initial 20 grams. Okay, so for the 20 grams, he's actually paying, the rate is 32 cents for that 20 grams. So answer 32 cents. Question 27. Gregory glued 9 unit cubes together to form the solid shown. Okay, you're supposed to draw the top view. Now, for the top view, right, you have to imagine you're standing here from the front, and then you look down. Okay, you're not standing at the side, you're standing at the front, and then you look down. Okay, so when you look down on the leftmost, right, the leftmost side, you see 2 cubes. So you start with 2. You use a ruler to draw this. Okay, 2. Then if you look across, there'll be 1, 2, 3, 4. Then below you have 2. So 2. Okay, this is what your diagram should look like. But B, Gregory glued more unit cubes to the above solid to form a cube. What was the least number of cubes used? So firstly, what's the smallest cube that he can form? So the smallest possible cube that he can form, right, without removing, will have a side as long as the longest part of this solid. Okay, and the longest side will be these 4 cubes. So your cube that you're going to form, right, it needs to have a side of 4 cubes. So the total number of cubes that you need will be 4 times 4 times 4, which is 64. You need a total of 64, but he already has 9. So how many more does he need? 64 minus 9. Yeah, answer 55. He needs at least 55 more cubes. Okay, question 28. 40 pupils helped to sell packets of popcorn at a school carnival. Each pupil was given 6 packets of popcorn to sell. Some did not turn up, so each pupil present had to sell 2 more packets to meet the required sale. How many students did not turn up? Okay, so firstly, there were 40 at first, right? But each pupil is supposed to sell 6 packets. So the total number of packets that they had to sell would be 40 times 6. Okay, 240. So no matter whether you have pupils not turning up or not, your total number of packets to be sold has to be 240. So because there were some that did not turn up, right? The rest of it has to be redistributed. So in the end, each of them, okay, each in the end would be 2 more. So at first it's 6, then 2 more, it becomes 8. So everyone has to sell 8. So how many were there? Number of pupils in the end. So if you had 240 to sell, and each of them had to sell 8, there will be 240 divided by 8. Means that there's 30 of them. So if the total is supposed to be 40 pupils, the number of pupils that did not turn up would be 40 minus 30. Okay, so 10 of them did not turn up. 29. A box contains beads of 3 different colors. 3/5 are red, the rest are blue and green. The ratio of blue to green is 2 to 3. What is the percentage that is blue? I'm going to write everything in ratio. So if 3/5 are red and the rest are blue and green. So 3 for red, 2 and green would be 2/5, so 2. Then blue to green is 2 to 3. Common base, the common base would be the total of blue and green. Would be a 5 here. So we try to make the same. 2 and 5 common multiple, 10. So there's 4, 6, and 10. So what percentage of the beads is blue? You want blue over total. So blue is 4. The total would be 25. So 4 over 25, you want percentage times 100%. So 25 and 100 you can simplify, divide by 25. This is 4. So 4 times 4 is 16%. Okay, so answer 16%. Question 30. A bakery had a number of cakes for sale. After selling 42 cakes in the morning and 4/9 of the remainder in the afternoon, it was left with 1/3 of the cakes. How many cakes were left? Okay, let's draw a model. So for this question, take note that we have 4/9 of the remainder. Then at the end, right, we have 1/3 of the cakes, which means 1/3 of the total. These two fractions, you cannot combine them. Okay, so firstly, you have 42. This is for morning. Then for your remainder, you have you want 4/9, so you're gonna cut into 9 units. Okay, I'll just cut this. You can redraw it below if you want, but I'll just cut it straight. 4 units for afternoon, and the rest will be the amount left. Now, the amount left, according to the fraction, is actually 1/3 of the total. And okay, so according to the fraction, 1/3 means 1 unit out of 3 units, right? So according to a fraction, you have 1 unit left. But according to the model, the amount left is 5 units. So I will change the fraction to be consistent with the model. The amount left is 5 units. So I'll change the fraction into 5/15. 5/15 now, which means that this 5 units is actually this 5 units here. So then what does it tell you about 15? Which means that 15 is the total number of units. Okay, so 15 units is this whole thing. So next, figure out what is 42 units. So if the portion of your remainder is 9 units, right? What's 42? It will be 15 units minus 9 units, which is 6 units. So 6 units is 42. 1 unit divided by 6, you get 7. Question is asking how many cakes were left. So left will be 5 units. We take 5 times 7. So answer 35. Okay, so with that, that's all for paper 1 Catholic High Prelim Exam 2024.